Our experiment is all about Newton's second law of motion. The experiment entitled Riding with the Wind. The purpose of this experiment is to investigate the relationship between the component of the force that propels a sailboat. The materials required or equipments are an illustration board, a yarn, a meter, a 5 cents as a mass on this experiment, a wire, bottle caps as a wheel, a pulley,
an electric fan. Discussion. In this experiment, you will use a small model cart and an electric fan. The physics of sailing involves vectors, quantities that have both magnitude and direction. Such directed quantities include force, velocity, acceleration, and momentum. In this lab, you will be concerned with force vectors. In Figure A, a crate is being pulled across the floor. The vector F represents the applied force. This force causes motion in the horizontal direction, and it also tends to lift the crate from the floor. The floor can be resolved into two vectors, one horizontal and the other vertical. The horizontal and vertical vectors are components of the original vector. The components form two sides of a rectangle. The vector F is the diagonal of this rectangle. When a vector is represented as diagonal of a rectangle, its components are the two sides of the rectangle. Whatever the direction of wind impact on a sail, the direction of the resulting force is always perpendicular to the sail surface. The magnitude of the force is smallest when the wind blows parallel to the sail. When it goes right on by without making any impact, the force is largest when the sail is perpendicular to the wind. When the wind makes full impact, even if the wind hits the sail at another angle, the resulting force is always directed perpendicular to the sail. The keel of a cart is a sort of fin on the bottom of the cart. It helps to prevent the cart from moving sideways in the water. The wind force on the sail can be resolved into two components. One component, K for keel, is parallel to the keel. The other component, T for tip, is perpendicular to the keel. As shown in Figure B, only the component K contributes to the motion of the cart. The component T tends to move the cart sideways and tip it over. Any cart with a sail can sail downwind, that is in the same direction as the wind. As the cart goes faster, the wind force on the sail decreases. If the cart is going as fast as the wind, when the sail simply sags, the wind force becomes zero. The fastest speed downwind is the speed of the wind. A boat pointed directly into the wind with its sail at right angles to the keel is blown straight backward. No cart can sail directly into the wind, but a cart can angle into the wind so that a component of force K points in the forward direction. The procedure of going upwind is called tacking. Procedure. Step 1. Position the cart with its wheels, the keel, parallel to the wind from the fan. Position the sail perpendicular to the wheels. Start the fan blowing on the front of the cart with the wind parallel to the wheels. Step 2. Direct the wind from behind the cart and parallel to the wheels, keeping the sail perpendicular to the wheels. Reposition the sail at 45 degrees angle to the wheels. Direct the wind behind, parallel to the wheels. step 3. With the fan perpendicular to the wheels, make a vector diagram for this case. Step 5. Repeat step 3, but direct the wind at a 60-degree angle to the wheels from the front. Set up a pulley on the edge of the table. Attach one end of a piece of lightweight string to the cart and thread the other end over the pulley. Attach a mast hanger to the string. Set the sail perpendicular to the direction of the cart. Place the fan directly between the pulley and the cart so that the full force of the wind strikes the sail at 90 degrees. Holding the cart, turn the fan on its highest speed setting. The wind force depends on how close the fan is to the sail. Place the fan close to the sail. Slowly add very small masses to the mast hanger. Continue adding them until the weight of the masses, including the mast hanger, just balances the wind force on the cart. The wind force is balanced when adding the smallest mass you have causes the cart to move forward. The pulley and removing the smallest mass causes the cart to move away from the pulley. Record the mass required to the balance cart. Step 7. Repeat step 6. But this time, orient the sail at a 45-degree angle to the wind. Record the mass and calculate the weight required to balance the cart.
Yun.